Dear friends, once again welcome. Let us discuss about now how to convert the UDL and UVL into point load. So that is required. Why it is required to locate the force or load, okay, calculation in the calculation of moment. So that's why the UDL and the VVL, this type of, and what is UDL? So UDL, uniformly formally distributed load. Like suppose this is a beam, and in this way, so you can see the intensity, the height, or intensity intensity of the load is same throughout the throughout the span, throughout the length. Okay, and suppose L is our length, and this is our A, and this is our B, and okay, this can be also represented in the form of like a rectangle with the same height and the direction downwards. And what is the unit? So unit, suppose it is 20 kilonewton per meter. So the rate of the load, okay, means distance wise. So in this way, the UDL. And what about UVL? UVL, uniformly formally distributed load. Like this is the beam, and the load is distributed like this way, here, here. So this is the maximum height. Suppose W kilonewton per meter. This height is the maximum intensity. Here the intensity of the load is 0. Okay, so see here, gradually it is increasing. Okay, so this is about UDL and UVL, and how to convert the point load into point load, that is also known as the concentrated load into uh, means the UDL into point load. Here either UDL or UVL into point load. How to convert it? So that we are going to discuss. So suppose the beam, this is the beam loaded with some intensity A, B of L length beam, and this is the height is same, so that's why W kilonewton per meter. Okay. So and this and for triangle, like this is the situation 1, this is the situation 2, and the length is L. एंड दिस इंटेंसिटी, ये जो नीचे की ओर एरो शो कर रहा है, द लोड इज एक्टिंग इन डाउनवर्ड डायरेक्शन and it is equally distanced. Okay, and this height is suppose W kilonewton per meter. Okay, so what we have to do, the shape, these are the shapes. Okay, we are going to convert it into point load, and this also we can, let us extend this third, this one and this one. It is trapezoidal shape. ठीक है, and length is L, it is A, it is B, and suppose it is of W1, it is of W2, Newton or whatever, Newton meter. Okay, it is also Newton meter. Okay, third one. Now fourth one, the beam name is here A, B of length L, and it is symmetric. Yeah, yeah. Okay. So now our task is to convert it into point load, and we have to locate the loads. Okay, so regarding shape, so shape, then equivalent, equivalent, equivalent point load, point load, then force equation, then लोकेशन. इन दिस वे आप टेबल बना सकते हैं एंड सी The first one we are talking about, first one means shape is what? Rectangle. Rectangle. Okay, so how to convert it into point load? So area and length is what? And intensity, so that is intensity multiplied kilonewton with the unit multiplied by L in meter. ठीक है, तो एम कटना चाहिए, एम कटना चाहिए, so what we get? W L, and that is equal to point load. ठीक है, एरिया फाइंड आउट करने से we can get. And so this itself what we are getting equivalent point load, that is the force equilibrium. Okay, so this we can write WL. Okay, this is, and where it is located? So it is located at L by 2 distance. Okay, because rectangle, so the point load will act at the mid, at the mid. Okay, what about similarly for triangle? Area, it is 1 by 2, and the height, this is the height, this is the length. Okay, and the same is here, the force equation, and where it is located. So it depends from where you're taking. So suppose from B, so from B, yeah, there is some problem. Okay, so from B it is, means we are talking about the center of mass, so it is L by 3. अगर इसी को from A, suppose you want to know where is the center of mass, so it will be 2L by 3. Okay, so from B, L by 3 from B. Similarly for fourth one, and this is trapezoidal shape, but what we will do, we will divide it into two parts so that easily we can understand it. Okay, and then this one, and what about the height? So this is W1, it's up to this W1, and this total height is W2. So that's why here this height will be W2 minus W1. Okay, and the procedure is same, where it is located, like this is A and B. So it is located, and this is what it is 1 by 2, then W2 minus W1 into L into L. This is the point load. Okay, so it is acting from L by 3 from the B. Okay, and there is a one rectangular shaped load. So it can be converted into point load, and it will act. This is A, B. It acts from A or B, L by 2, and this load will be what? So this load is P is equal to this P is equal to the total length and height. So height is what? That is, here we can see this is W1. So here also W1 you can see in the figure. Here this one, this one. So that's why P is equal to W1 multiplied by L, total length, and where it is acting. So it is acting from A, L by 2. So this can be now drawn. The beam it is A, this is the beam, it is A, it is B. So due to the, this is suppose P1, due to triangular, due to triangle, and it is L by 3 distance from B, and at the mid it is P2, and it is due to rectangular load. So in this way we have converted the trapezoidal load, means the beam with the trapezoidal load, into the point load. Ultimately we have to draw the free body diagram for the analysis. Okay, next one, the fourth one. So what is our task here? Firstly we have to get the point load, okay, and second, location of this point load, and third, C, it suppose at x distance from A, we cut the section, then what will be the intensity? What will be the load intensity? The load intensity. means what we have to do, this is the beam A B of length L and it is symmetric. Okay, and the load is of this load is the maximum height W Newton per meter. Okay, so what will be the area, means this get the point load, that is the area is equal to total load, and this is equal to 1 by 2, and oh, it is symmetric. So this triangle, two triangles are here, so this is triangle 1, triangle 2. So you can see the any triangle, so this height and we have to multiply with this distance, so it is L by 2. Okay, so 1 by 2 and W then L by 2. So this is the load WL divided by 4. We have converted that into point load and where it is acting. So similarly where it is acting, so from A it is the length of means 2/3 of length, okay, beam length, so that is here L by 2. So here it will be 4, no sorry, it will be the L by 3 to L, yeah, L by 3, it will act L by 3. And what about the intensity? So this intensity is W and unit here is Newton meter. So what about if you cut this section, if you cut this from here, okay, and it is x distance. So what about the intensity of this? This is what? This intensity is what? So easily we can get it. So at L by 2 it is W Newton per meter. Okay, so what about at x distance? The x distance, what will be this, then multiplied by x, and here x is equal to, then x is equal to 2 wx divided by L. So this is the intensity. This is the intensity. Here we get this equal to 2wx by L. So in this way we have done what we have done. We have converted the either UDL or UVL into point loads for the different shapes of the loadings, like rectangular, triangle, trapezoidal, and triangle, the structure with the symmetric triangle, and how to uh, gauge the load intensity if you cut the section, okay, any anywhere, then how to get the intensity, like we know, yeah, in fourth condition, see, fourth case, we know the maximum height, and that is W. But what about here? What is the intensity? Here, what is the intensity? Here, what is the intensity? So that we can get by assuming some x distance from any end, either A or B. So in this way we have done. Thank you.